All right, just going to finish off our first section on, well, basic algebra, basically, we've been looking at. So simultaneous equations. Most common way of doing it is what they call the elimination method, because you eliminate a variable. And so once you eliminate a variable, you then go and solve for the other variable, and then you substitute back in and work out what the eliminated one was. That's the basic idea, of course. So here's a very simple one. And we just basically try and make the coefficient of either the x or the y, in this case, the same. Doesn't matter about the sign, of course. If they're opposite in sign, instead of subtracting the equations, we just add the equations. X's or y's, what would you like? X's. Which one did I do? I did the y's, it looks like, doesn't it? So multiply the first by 2, second one by 3, and there's our two new equations. But now the coefficients of y are the same. So we can subtract, and we know 11x is negative 33. X is therefore 3, and we can substitute back in and work out y is 9. Now, a couple of things about my working out there. I probably put more working out in than you in reality do. Possibly you wouldn't write the actual line down, you know, multiply 1 by 2 and so on. And even the substitution, depending on how complex the equation is, you might not show the substitution step because you might be just going, oh, yeah, okay, therefore y is this. But when you are writing the answer down, make sure you answer the question correctly. I purposely use the pronumerals x and y because they are also the pronumerals we often use in coordinate geometry. And so the incorrect way of writing this answer would be to write down a set of coordinates. Nowhere in here does it say find where two lines intersect or anything like that. So the correct way of writing the answer is x is negative 3, y is equal to 9. It just happened that the pronumerals I used was x and y. Okay, if it was a question in coordinate geometry where we're trying to find the point of intersection of two lines, and so we then turn it into this sort of question, then the answer would be coordinates. Okay. All right, 2x plus, got a problem here. I can't make the coefficient of the pronumeral the same because none of the pronumerals are the same. Whilst we've got x's, x and x squared are of course different pronumerals. So this is where we have to use the other method of course, the substitution. We make one of these pronumerals the subject of the particular equation that it's in. So we've actually got four choices. We can make x the subject, y the subject, x squared the subject, y squared the subject. It is more sensible to choose the ones that are to the power of 1, of course. So I'm going to make y the subject. Why did I choose y? Oh, too many y's there. Because the coefficient of y is already 1, so it makes it nice and easy to make the subject. Basically, that's why I picked it. But it doesn't matter. So y equals 14 minus 2x, substituted into the other one, and we end up with a quadratic equation. Amazingly, it factorizes 3x minus 41, x minus 5. So there's our two possibilities for x, but that therefore means now there's two possibilities for y. So subbing in, again, when we write our answers down, make sure you match them correctly. Don't say x is this and this, y is this and this, because that would imply there's four possibilities. You can mix and match whatever you like. Actually write the correct pairings down. So x equals 5, y equals 4, or the other case, 3. Okay. Theoretically, anytime you've got the same number of equations or more than the number of pronumerals, it should be possible to solve them simultaneously. Now, I don't know how many you've done with 3 pronumerals. We've done 3 pronumeral simultaneous equations before. All right, so some are going yes, a couple are going, oh, not sure. But the idea is basically the same, of course. So the first thing we do is we want to create a new pairing of equations and eliminate the same variable from each pair. So the first one I'm going to multiply by 2. That now makes the x's the same, and so I can eliminate the x's from that equation. Now I can pick any other pair and do the same. Eliminate the x's from that one as well. So I'll now multiply the first one by 4, and match it up with the third equation. And I can eliminate the x's there. Now we've got our standard sort of simultaneous equation question. Two pronumerals, two equations. Let's solve them. And I've made the z's the same. So finally now I get y is -2. I can then go back to one of these two equations and work out z is 4. I can then go back to one of the first three equations and x is 3. So there we go, x is 3, y is -2, z is 4. All right, that's enough. Oh, triple asterisk on the 9. Must be a good question.